Hello. This video is going to discuss some of the what we call the kinematics equations that we use in AP Physics 1 to describe how objects move, excuse me, and how concepts like speed, velocity, time, displacement, and acceleration all interact with each other. So we're just going to kind of start going through the equations. I'm going to describe and discuss what each of the symbols mean in these equations, and then also some of the types of problems that we might use these equations for. So starting at the beginning, we had an equation that looks something like this, where it is a v with a line over the top equals, it's a triangle x or delta x. This triangle is a Greek letter delta, which is basically like a Greek letter D. That's the capital delta. For those of you in calculus, right, the formula for a derivative, or the little symbol for a derivative, is actually lowercase delta. So say a capital delta, x, lowercase x, and then a t. And this formula, what it describes is an average velocity. I took the velocity, if I could spell, this would be good. I took the symbol kind of from a thing from statistics, where line over the top in statistics means mean or average. So v is velocity, line over the top is average velocity. Triangle x stands for the displacement, and we've had several discussions on what displacement means, so I'm just going to leave that at that. And t stands for the time interval. And in other words, it is what time interval is needed to cover this displacement. Kind of one of the bad things that sometimes people use when writing out story problems for these is they'll say, how long? Is it how long does this take? And that's really kind of a bad thing to say, because long could kind of mean a distance or displacement, and long can also be a time interval. So I'll try very hard to say what time will it take, or the time it takes is, rather than saying, you know, if this is the velocity and this is the displacement, how long did the trip take? You know, I'll try to say what time did the trip take, just to kind of make that distinction. Okay, so this is a formula that does work. There have been several instances in class where I've given you some different situations and said, what is the average speed? I mean, if I give one of the examples, you know, that we could give is something like, we're going to go 30, we'll just use miles per hour, you know, for 1 hour, and then we go 50 miles per hour for 4 hours. You know, what is the average speed? And some of you are so used to math with taking averages that you just want to average the numbers, right? Take 30 miles an hour plus 50 miles an hour and divide it by 2 and get 40 miles an hour and say, hey, that's the average of the two numbers. Well, it is the average of these two numbers, but it has absolutely nothing to do with average speed or average velocity, right? The difference being average speed, if we know the distance and we know something about the path, average velocity if we're interested in displacement. Now, if we assume that this object's traveling in a straight line exactly, it won't make any difference. So let's just assume this object's going in a straight line. All right, so if we want to do average velocity, like I said, I wouldn't just average these numbers. We always need to go back to the original formula and let that kind of guide our thinking in terms of how this works. And our formula says, if we want to know the average velocity for some trip, we need to know what is the total displacement for that trip and what time interval did that displacement take in terms of you know, how many hours or minutes or whatever. Which is another thing. When we do these, we want to make sure our units match up. Right? If this is miles per hour, we need to be measuring our time in hours. You know, same thing on this side. If we have minutes, either we need to change this into miles per minute or change the minute into hours. And we'll do more of this unit analysis as we go throughout the year. And that should start to make more sense the more of those that we do. But in this case, for this problem specifically, it's pretty easy, I think, to figure out the overall time interval. Because here we traveled for 1 hour, here we traveled for 4 hours. So if we're trying to figure out what is the average velocity for this entire trip, it's going to be our displacement divided by 5 hours, because that is the total time that we were on the road. So our question is really, what is our overall displacement? Well, excuse me. Man, cough tonight. What we can do is we can go back to this equation and now actually use it twice. We will use it once for this set of numbers and try to use that to find out the displacement. And we can do the same thing for this situation and try to find out what is the displacement. But in this case, I think the numbers are easy enough. We can probably kind of logically work through it. If we're traveling 30 miles per hour and we travel for 1 hour, I'm hoping it's obvious that this object or you or whoever this is travels 30 miles during this part of this motion. And if we travel 50 miles per hour for 4 hours, once again, I'm hoping it's kind of obvious that overall you can travel 200 miles during this portion of the motion. So 30 miles plus 200 miles altogether is 230 miles. And if we travel 230 miles in 5 hours, then this is going to be 46 miles per hour, which is significantly different than the 40 miles you would get, miles per hour to get if you just average these numbers together. Once again, you can always average two numbers, but it may or may not have any basis in reality. And we find out for this problem, there really is no basis in reality in terms of trying to find out an average velocity, because average velocity is the total displacement divided by the time interval that it took. And for this little example, we found out something like this. So anytime we're being asked for average velocity, this is the formula I would use. Now, sometimes it may not necessarily be obvious that that's the formula. Let's just say that we know that something travels at a constant velocity of 35 meters per second. Right. What time is needed to travel 500 meters? Excuse me. So as we've talked about in class, what we're trying to do with story problems like this is kind of annotate and decipher which each of these different numbers mean. 500 meters, right, with just meters, hopefully, obviously, that's measuring the displacement. Right, if we have 35 meters per second, that is a velocity. But it may not be immediately obvious what kind of velocity that is. It just says constant velocity. Well, here's the thing. I know we've talked about in class several times that if we're going in a straight line, because once again, and these problems we can assume we're going in a straight line unless it's otherwise mentioned that we're going to turn or do something like that. That if we're at a constant velocity the entire time, the constant velocity will be the average velocity for the entire trip. So what you can automatically somehow put in your head is anytime it says constant velocity, this is the formula again. Constant velocity means we're going to be using the average velocity formula, because once again, if we're going in a straight line and our velocity is constant, the average velocity for that trip will be the same number as that constant velocity. If we are going 500 meters in a straight line, I can guarantee that if we have a constant velocity of 35 meters per second, the average velocity for that trip will be 35 meters per second. So now we're doing the math. 35 meters per second is the velocity, and that's going to equal the displacement, which we know, over the time interval that it takes, which we don't. That is what we're looking for. So once again, if we're kind of diagramming this out, I should have done this too, right? Time means t. And as we said, the velocity there is going to be an average velocity. You really need to get in the habit of annotating these story problems with, circling, underlining, highlighting, whatever the important information, and then trying to match it up to which concept that corresponds to, and then matching that up to the symbols so we can find the correct equation to use. Now for this one, it's how do we do the math? I always suggest if there's fractions in one side of an equation, we just turn both sides into a fraction by dividing the other side by 1 and then cross multiplying, right? Top times bottom, 35 meters per second times t equals 500 meters times 1. And then to isolate the t, as the mathematicians would say, we divide both sides by 35 meters per second. And the time is going to be 500 meters divided by 35 meters per second. And unfortunately, I'm using my cell phone to record this, which is also my calculator. So I will let you do the math. What I will say is the meters here are going to cancel out. And here we have a per second on the bottom. And if we have a per second on the bottom of a fraction, in the bottom of a fraction, this is the old invert and multiply rule, right? Like dividing by 1/2 is the same as multiplying by 2. Here we're dividing by a per second, which, since that's already in the bottom of a fraction, it's going to flip, and our units will actually be seconds. So it's 500 divided by 35, whatever that number is. Seconds is our time interval that would take. Okay, so that is that equation. Right? It is displacement versus time, displacement with time to give us our average velocity.